Now it's in zone. All right, try this again. W, you're going to make sure that you mark speeding up for W because you're going faster, 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 faster than you get to here. Make sure you're marking this as no motion. So horizontal is this. This is motion. The steeper the slope, the faster the person or the car or the object is going. When the graph gets to this motion here, that means it has stopped when it has the distance on this side. When the distance is over here, it's not going anywhere. If position was over here, it would be in the same position, and we'll do position later. For distance time graph, this is no motion. Faster, 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 fastest. Okay? So that is why this on your homework was the fastest, and this is a constant speed. This is fast at a constant speed. Okay, so make sure you mark this on your graph in your journal. Okay, and then Z is this motion here. What is this motion? No motion. So Z is no motion. Okay, make sure you're filling that out. Make sure that you notice on these graphs, you've got to pay attention to the axis here. This is your y-axis, and this is your x-axis. This is always going to be the distance or the position. This is going to be what you're actually measuring. This here is always going to be your time. And make sure you notice what it's in, if it's in minutes, or if it's in seconds, or if it's in hours. So your answer here, the reason why I want you to write this down at the bottom, every answer will be in meters per second because it's meters here and seconds there. So write that down on your graph. Every answer is meters per second. Write it down. And, oh, here it is. Okay, we're going to go to the next graph. Okay, so on this graph, you have 62, zero. Okay, we're going to go down. You already have, well, I went a little bit too far, so I'm going to stop right here. I went too far, so I'm going to stop right here. And then it's going to be by tens, 20, 30, 40, 50, 60, 30. Okay, so this graph here, 2, 4, 6. Okay, so it's going to go up to on the 2 at the 20, on the 2 at the 20. Then it goes to 20 to 30, so we're going to go from here, and then we're going to go 20 to 30, okay, and then we're going to go down to number 1, which is between 0 and 2, on the 40, so we're going to go down to here, on the 40, okay, and then we're going to go from there up to 5, which would be right here. We'll go across on the 50. So we're going to go up 50 to about 5, which is right here. Okay, and then we're going to go across to 60, which is right here. Okay, so this is movement. I'm going to show you the movement. That's it. That's the movement. Okay? I mean, I can't walk the whole room, but I'm going to move at a constant speed here. Okay? So this is a constant speed. So we're going to label it constant speed. Okay? So that's a constant speed. Now what? What'd I do?
No motion.
Stop. So it's no motion. No motion. Okay, so no motion. What'd I do?
You moved.
I went backwards. Okay, I went backwards. Okay, now I'm going to show you the next motion.
Faster.
Fast. Yes, this is fast at a constant speed. Okay, so if I go from, what is this? No motion. Good.
We're getting better at this.
Yeah, that's why we're doing this. So when you do your videos today with your QR codes, you're going to be looking at a car and the car is moving. Now you're going to have to do the graph. We've been talking about the graph and labeling what the graph is doing. Now you're going to see an activity with a car moving
So
and you
make
have
it
to
yourself?
graph it. Hmm?
So you're gonna make the line?
Yes, now you're going to make the line. So now you have this, you have this, and you have that, which we need to go to on your
Homework.
homework. Okay, we need to finish that part. Okay?
Yep.
So on your homework, we're here. Alright, so the graph shows an ant moving in a straight line. If the ant moving at the same speed, how far will it have traveled at the end of 30 seconds? How far will it go? Here's 30. It's moving a centimeter each time, so how far would it be? If it's moving a centimeter each time, how far will it be? How far will it be? 6 centimeters. So for number 4, you should have 6 centimeters because it's moving a centimeter each time. And all you're doing is getting to 30. How many have 6 centimeters? On number 4.
Nope.
You have 5?
Yeah.
Okay, well 5 would not be the end. It said, if the ant moving at the same speed, how far will it have traveled in 30 seconds? 6 is the answer because it has to get to 30.
You have to go up to 30.
You're absolutely right. It has to get to 30. So here, if you went to 5, 5 is at 25. 5 is not at 30. Okay, what is the speed of the ant in this graph? How far did it go? How far did it go?
20 centimeters.
It didn't go 20 centimeters. How far did it go?
Is it
6. I got 5.
5?
1, 2, 3, 4, 5, 6, 7 is all you have as your answer choices. It stops here. So how far did it go?
4.
4 centimeters. In how many seconds?
20.
20.
4 centimeters.
So what is your speed? I'm covering up what you're trying to find.
Distance divided by time.
There you go. Distance divided by time. So what is my distance?
4 divided by 20.
4 divided by 20 is what?
5.
4 divided by 20 is 5?
Yes.
Yeah.
4? 4 divided by 20.
Yes.
Oh no.
4. Use your calculator. 4 divided by 20 is what? It's 4. Not 20 divided by 4. It's distance divided by time. It's distance divided by time, not the bigger number divided by the smaller number. What? Well, what did your calculator come up with? What does your calculator say? Check it with your calculator. What does your calculator tell? No, not your hand done division. Your calculator. What does your calculator tell you? We check everything with a calculator in science because of the mistakes.
4 divided by 20.
What is 4 divided by 20? I want to see it on your calculator.
0.2.
Yes, 0.2. You have to remember that it is distance divided by the time, not the time divided by the distance. Okay.